Hi, Sam here from Roberts Geospatial. This is the first video showing you updates to ProRaster Scientific as I develop the software. So one of the major goals of ProRaster Scientific is to allow users to acquire a satellite scene from a provider like the USGS and then to display that satellite data appropriately and correctly in ProRaster and then do analysis of that data. So in my previous video I talked about Landsat data and all of the different ways that it's been provided over the years and how those formats have changed and all the data that's been delivered has changed and there's a lot of complexity there. So the first phase of the development in ProRaster Scientific is to take away all that complexity from the user. So the goal is for the user just to point ProRaster Scientific at a satellite scene, import it, and then start using it. And it doesn't matter what it is, or what collection it is, what level it is, what level of processing and so forth. ProRaster figure all that out for you and bring the data in an appropriate way. So let's have a quick look. Don't worry about the user interface, that's just preliminary. So we have a button here called Add Scene. So if I go Add Scene, I can then browse to some satellite data. So if we go to Landsat, for example, the latest data, so it's collection 2, level 1, you go into Scene. So here's the sort of thing that we're looking for. In Landsat, they supply you with an mtl.txt file. That's the key file that we'll be looking for Landsat to figure out what's in that scene. So you select that, and then it does some processing and creates a virtual raster. So I'll talk about that in a minute. Now, if we were to do this for Sentinel, so let's come back up to here, go into Sentinel, say level 1. Sentinel has all these horrible names, but there's a file in there called mtd_something.xml. That's your key file in Sentinel. So you select that, and then that will do the processing on that file. And then the alternative to that is to say add a folder, and you just point it at the folder, and it will do the processing, or you can point it at some top-level folder, and it will do the processing on everything that it can find in that folder. So if I go to my top-level satellite folder and select that, then it will do the processing, and it finds about 100 satellite scenes in that folder and processes all those scenes. Now that will go into a database, and then you'll be able to work from that database. But the result of that processing is a small file. So let's have a look here. So all of that processing spat out a file for each scene. So this is what they are. So there's a single file for each scene, and it's an MVR file, and that's a virtual raster. So you can then take that virtual raster and put it back into ProRaster. So let's do that. So if I take, for example, Landsat, so this is Landsat 9, it's level 1 processing, and it's collection 2. We can tell that from the file name. So I'll drag and drop that into ProRaster Scientific. So let's just have a look at what's in this virtual raster. In the MapInfo raster system, we have this concept of fields and bands. So in systems like GDAL and like formats like GeoTIFF, there's only a concept of bands. So you can have a multi-banded raster, but in MapInfo we support multiple fields and then multiple bands for each of those fields. And that allows you to store different kinds of data in a raster. So fields will have a particular type. They might be continuous data, so that's sort of multi-banded multispectral imagery, for example. Or they might be imagery, in which case there's going to be some kind of color data value. Might be classified, in which case there's going to be a classification index and some kind of classification table. Anyway, it allows you to group your data by type and also logically into to separate the bands out into logical groupings. So we've brought in Landsat 9 and it's produced this virtual raster, and this virtual raster has a whole stack of fields, and here they are all listed here, so we can select any of these fields, and each of these fields has multiple bands. So you can see that the first field there is spectral DN, which is digital numbers. So these are the spectral bands that came straight from the USGS, and here they all are here, band 1, 2, 3, 4, 5, 6, 7, 8, pan-cirrus. Now, when I display that in ProRaster here, you can see it displays out here. There's no duplication of any of the data. So this is going back to the original TIFF files that were supplied from the USGS. So that's our spectral numbers. Then we have our thermal digital numbers, and here we have band 10 and 11. They're the TIRS instrument. So the next field is spectral, top of atmosphere, radiance. And you can see there are three like this. So there's spectral top of atmosphere radiance, top of atmosphere reflectance, and then top of atmosphere brightness temperature. So these bands are computed on the fly from the original digital number bands. And that's using metadata that's supplied with the scene. So the conversion from digital number to top of atmosphere radiance or reflectance is basically just a fairly simple transform, as well as a solar correction. So we're performing that on the fly when we select this in ProRaster. So I'll select top of atmosphere radiance, and in here you can see you've got all your bands. Select pan, for example. If we go to reflectance, there's a shorter list of bands. Not all the bands are converted to reflectance. The TIRS bands are not converted to reflectance. And then in top of atmosphere temperature, we've got our TIRS bands. Now this is doing a fair bit of work behind the scenes because it has to do a solar correction based on the solar azimuth. Now for collection 1, that solar correction was just based on the center of the scene, the position of the sun at the center of the scene. But for collection 2 data, they supply a solar azimuth raster, so you can do the correction per pixel in these bands. So that's what's happening here. So we're doing a solar correction per pixel, and we're doing the scaling for top of atmosphere. So that's top of atmosphere. Then you can see we have ancillary data. And in there's a bunch of fields. So this is the data that gets supplied with the scene, but isn't spectral data. So we've got our solar azimuth and solar zenith and so forth. Then we have QA. So I'll select QA, and in the QA field we have the pixel QA, and then we have the radiometric saturation QA. There usually isn't much in that. But in the pixel QA we have useful data. So pixel QA is a 16-bit number, and each bit in that number means something different. And often multiple bits combined means some kind of particular information. So it's hard to pick information out of that, and that's why, and so you have these numbers here which are kind of meaningless. And that's why I then go on and produce QA pixel values. Now in this field, I pick out all of the individual information from that QA field. So here we have cloud, for example. So where we have zeros, we have no cloud. Where we have 1, we have cloud. Or you might have your cloud confidence. So 0 for no confidence, 1 for, well, essentially no confidence, and then 2 and 3 for cloud confidence. You can also see that there's shadow, cirrus, snow, water, and so forth. So that field just picks the data out of that 16-bit QA value and makes an individual raster out of it, which you can then use in your processing. It's the same with the radiometric saturation. So There's all sorts of different bands in there, terrain occlusion, and in the other bands for the different spectral bands. And then finally, I have this mask field. And the mask field is derived from the QA data using some raster calculator operation. And this is something that you can use more generally. So I have pixels that are completely clear, pixels that are partly clear, and then classifications for land, water, and snow that are completely clear. So what I'm aiming to do is to have a filter that filters out all the bad pixels. So let me just show you how you would use that. So I'll add a red, green, blue color layer, and come into here, we'll select that virtual raster. Let me just delete that lookup table color layer. So let's just do 4, 3, and 2, which is your standard true color. Then go on to the mask component, and this is new in ProRaster Scientific. Select that virtual raster, go to the mask field, and I'll just click, for example, clear land. So when we turn that mask on, all of the ocean that was out, sorry, I'm pointing with my finger, I should point with the mouse. All of the ocean out here has disappeared. This lake down here has disappeared. Let's turn that back on. We have a lake down here. We have ocean off here. Here's all our land, but you can see that we have cloud through here, through here, through here. So when we turn that mask on, all those pixels that are affected by cloud are removed. Those pixels that are ocean are removed, and water are removed. Similarly, you could choose water. So now we're just seeing the water, the lakes, and we're seeing the Murray River there. Or you could just choose all pixels that are clear. So now we're getting land and water, but anything that's affected by cloud is being masked out. So that's how you use that mask field that's automatically generated when you look at when you import a satellite scene. So just very quickly, maybe we'll just look at some other ones. So if I come down here, say to this one here, this is a Sentinel-2 scene, and it's level 2, so this is surface reflectance. So if we have a look at what we have here, or am I wrong about that? Oh no, it's level 2. Yeah, so here we have surface reflectance. So our spectral bands are spectral bottom of atmosphere reflectance, and in here we have all the bands that are provided by Sentinel. Then in the ancillary data field, there are a couple of things provided: water vapor, aerosol optical thickness. And then for Sentinel data, they don't provide QA data in the same way that Landsat provide it. They actually provide a classification. So each pixel has one value, doesn't have the possibility of multiple values per pixel. So that's a classified raster. So we have this classified field, and in here you've got your color and red, green, blue, and class. So if we just turn on the value, you can see these classifications. So not vegetated, cirrus, vegetation. Up here we've got water. So that's a classified raster. And then we have our mask channel. And this time the mask is derived from the classification field. So we have pixels that are clear, pixels largely clear and partly clear, and then we have land, water, and snow. So if we go to water, for example, you see it's picked out a lake there, whereas land, that lake disappears, and this is all cloud. Go to clear pixels, we have all that cloud. Go to largely clear, it comes in a little bit. Partly clear, that's just the thickest cloud then that's being filtered out. And then finally, you have a imagery field. So this is an image that's shipped with the Sentinel. So if we go to that one, choose that, use the imagery, real color. So there's the image that actually gets shipped with that Sentinel scene, which you can use as a reference image. So that's Sentinel data. Now, depending on what you download, there's going to be all sorts of combinations of different things. So that's just a taste for what you'll see. So what will happen is you'll do that import process. It'll create that virtual raster for you. That goes into a kind of a database, and then you'll work from that database. And from there, you'll generate your algorithms for different band combinations. You'll generate your mosaics. You'll generate your time series. You'll also generate your index calculation rasters. So it'll create virtual rasters that compute all the standard indexes for you, depending on what spectral data is in your scene, and which will of course limit what kind of indexes you can compute. And then you can go on from there and do analysis on that index data and so forth. And that's further down the track. But for now, I just wanted to show you that, show you that import process takes you from a collection of data that you might be forgiven for being confused about what you actually got, to something that's organized. You've got all the data available to you. All the key information has been picked out and is available to you easily, and you can use that in your rendering and in your processing. So thanks for watching. See you next time.